Okay, so what we're doing here basically is we're just looking at, say we want to find y when x equals minus 3. If we go to where the x value is minus 3, we go down to the equation and we look across. That'll actually give you the y value. So y value will also be minus 3 there. If we look at this, if we look at x equals 2, right, we go to the y value, we go across, we read off, the y value will be minus a half. And you can also see, if you sub that in, 2 minus 4 on 3 times 2, and you figure that out, that'll be 2 minus 2 fours are 8, 8 on 3, which is 2 minus 2 and 1/3. So it's actually minus a third. It's not even minus a half. It's minus a third if you did it algebraically. The same as this one. If you put in x equals minus 3, y is 2 times minus 3 plus 3. Y is minus 6 plus 3, so y is minus 3. So I think the point is you can read it from the graph, or you can do it algebraically. So if you put in y equals 2, y equals 2 is there, you can read off straight away the x value will be 1. If you did it algebraically, where the y is, you're going to put a 2. So 2 is 3 minus x. 3 minus what is 2. Or if you use your equation work, take 3 away, so minus x is minus 1. And then divide by minus 1. X is 1. You can see x value is 1. When y equals minus 2, if you go to minus 2, you can see the x value is 0. If you did it algebraically, minus 2 is a half x minus 2. The minus 2's go out. If you add minus 2, add 2 to both sides, they'll go out. And you get a half x. And then if you times both sides by 2, 0 equals 2 times a half is 1. So x will be 0. That's algebraically. Okay, so for this one, the first one, that's when x is minus 3. So you put in x is minus 3. What do we have? Y minus 3 equals minus 3 minus 4. Y minus 3 is minus 7. Y is minus 7 plus 3. Y is minus 4. So that'll be minus 4. Then this one here, we want to find the x when y is minus 5. So in place of the y, we put minus 5 minus 3 is x minus 4. Minus 8 is x minus 4. X minus 4 is minus 8. Plus the 4 plus the 4. Minus 8 plus 4 is minus 4. Oh, wait a minute. Minus 4. So that'll be that. So let me just check that if I put in... Yep, that works. Just checking it. Alright, so if we look at the next one, when x is minus 1, what's going to happen? So we got y minus 3 equals minus 1 minus 4. Y minus 3 is minus 5. Y equals minus 5 plus 3. Y equals minus 2. That's minus 2. Okay, when the y value is 6, so when y equals 6, that means 6 minus 3 is where the y value is. I'm just going to put 6 equals x minus 4. 6 minus 3 is 3, x minus 4. If you plus 4 to both sides, plus 4, you get plus 7. So x will equal 7. So when x equals 7, y equals 6. Okay. So let's have a look at the next one. When x equals 3, when x equals 3, so you got y minus 3 equals 3 minus 4, because where the x is, I put in a 3. So y minus 3 equals 3 minus 4 is minus 1. So plus 3 plus 3 minus 1 plus 3 is positive 1. When x equals 5, y minus 3 equals 5 minus 4. Y minus 3 is 5 minus 4 is 1. Then just plus 3 plus 3. Y 1 plus 3 is 4. Okay, so fill in the missing table of values above. And if you plotted all these points, you would see they all lie on the same line. Just with this one here too, if you wanted to get that into y equals mx plus b, you would add 3 to both sides, and you get y equals, the 3's go out, minus 4 plus 3 is 1. So that line, actually, y equals x is like that, so at 45 degrees, and then minus 1, that'd actually be down here. They have a y-intercept as 1, and the gradient is 1 on 1. Okay. Alright, if you look at this next one here, so the equation is 3x minus 10 equals 2y. Now rearrange the equation so you have y equals, okay? So 2y is 3x minus 10. So if you divide by 2, divide by 2. Cancel out. Y equals 3x on 2 minus 5. So when x is minus 2, y is 3 on 2 times minus 2 minus 5. You could put that in your calculator. You end up with minus 3 minus 5 is minus 8. That's minus 8. Okay, if you put in x equals 2, then y is 3 times 2 on 2 minus 5. 2's go out. 3 minus 5 is minus 2. When x equals 4, okay, so when x equals 4, y equals 3 on 2 times 4 minus 5. 2 goes into 4 twice. 3 2's are 6 minus 5, y would be 1. When x equals 9, let's see, 9, y equals 3 on 2 times 9 minus 5. I'm just going to highlight this equation so you can see where I'm getting it from. And I'm just putting in the 9 where the x is. So 3 9s are 27. 27 on 2 minus 5. 2 goes into that, 13 and a half minus 5. 13 minus 5 is 8, so it's 8 and a half. Okay. Alright, so now we're just going to do 7. So y equals 3 on 2 times 7 minus 5. 3 7s are 21 on 2 minus 5. 21 is 10 and a half minus 5. 10 minus 5 is 5. That'll just be 5 and a half. So rearrange the following equation so it's y equals, and find the corresponding y values. Okay, so we've got minus 2y equals 8 minus 6x, which is 4 there. So that's plus 4. So let's take away 4 on both sides. 8 minus 4 is 4 minus 6x. Okay, then divide by minus 2, because we want to get rid of the minus 2, and it's minus 2 times y. The minus 2's cancel. 4 on minus 2 is minus 2. Minus 6 on minus 2 is plus 3, so it's plus 3x. So it's actually 3x minus 2. That's the gradient, and that's actually the y-intercept. Okay, so now put the values in. X equals 1. Y is 3 times 1 minus 2. 3 minus 2 is 1. X equals 3. Y equals 3 times 3, which is 9. 9 minus 2, which is 7. X equals 5. Y equals 3 times 5 minus 2. 3 5s are 15 minus 2 is 13. Do you notice that they are going up by, well, they're going up by 6. So, yeah. See how the gradient is 3, but then these are doubling. That's why normally they go up by 3, but because it's doubling, that's why it's 6. So x equals 9, y is 3 times 9 minus 2. 3 9s are 27 minus 2 is 25. Okay, and right, that was 13, wasn't it? And x equals 10, y equals 3 times 10 minus 2. 3 10s are 30. 3 times 10 is 30. 30 minus 2 is 28. So it's probably good to watch Gradient General Form. because if you watch the gradient general form, it'll give you an idea of rearranging it. So you've got in the form of y equals mx plus c. So that's usually when you're trying to find the gradient, which is the number in front of the x, and the y-intercept, which is the c.